Hello, in this video let's discuss third question of today's contest. A zigzag array of length n is defined as follows. Each element lies in the range L and R. No two adjacent elements are equal. No three consecutive elements form a strictly increasing or strictly decreasing sequence. Return the total number of valid zigzag arrays. Since the answer can be very large, return it modulo 1 in n plus 7. A sequence is said to be strictly increasing if the element is strictly greater than the previous element. N is up to 2000 and L and R are also up to 2000. For example, if n is equal to 3 and L is equal to 4 and R is equal to 5, every element should be between 4 and 4, 4 and 5. No two adjacent are equal. No, the no three consecutive should form a strictly increasing or strictly decreasing sequence. So only there are only two possibilities: 4, 5, 4 and 5, 4, 5. Because 4, 5, 5 that is not possible. 5 and 5 are equal, and similarly only these two are possible. We have to return 2. So every element L and R, no two adjacent are equal. No three should form increasing or decreasing sequence. What is this? So find the total number of zigzag arrays. So firstly let's take length 3. So if we take length 3, then what are the possibilities we can have? So we have 3 elements, so we have two types, whether it is increasing, decreasing, or decreasing. So if both are increasing, then it forms a strictly increasing. If both are decreasing, it forms strictly decreasing. So these two are not allowed. So only these two are possible. So return answer 2. So let's take big array and we are at index 0. So if we are at index 0, then we can try all the elements from between 0 and 3. So we can take 0 and we can find the answer. We can take 1 here, we can find the answer, and so on till from L to R, because we have to find the number of ways. So we have to find all the possible ways to do that. So we can select any number presently, and then based on the present element we can find the total number of arrays possible. So let's assume that we are taking 0. For example, let's say we are taking 0. So if the possibility at the present index is fixed, then how to find for the rest of the array? So let's say that we are using a function that returns this answer. So function of index is that very simply possible. So if function of index returns the number of possible ways to get the answer, then we can directly add function of index when we are taking 0, when we are taking 1, when we are taking 2 or 3. But how can we make sure that two elements are not equal? For example, if we are at 0. So if we blindly assume that function of length, the function of index will return the correct answer, then how we are making sure that the next value is not 0? How are we making sure that the given condition satisfying? We cannot make sure that, right? Because if the only information that we are storing in function is index, then how can we make sure that both elements are not equal? So this is not possible. So what if we try to store function of index comma value? So what if we try to return function of index 1, because 0 1 index 0 is already taken. So what if we say function of 1 comma 0 will return an answer, and that is valid for value 0? Then this is fine for now, right? Because if we are taking 0, then if we pass in the parameter 0, then when we are checking possibilities for that, we can skip that number, because both adjacent cannot be equal. So function of index comma value can be a possible valid good one. But coming to next one, but there is a possibility that, but there is a condition also that no three adjacent should form increasing or decreasing. So how to handle that? So even now that is not possible, because we are only taking care of the next two elements. But what about the rest of the next one? For example, we are at 3, we are at 4. So here we will pass to the next index that we want the function of next index and value 3, because we use it 3 here. And let's say we are thinking for 4 now. Let's say we are L is 0, R is 5. So we are taking all the possibilities, and now currently we are at 4. So if we are at 4, then what will be the next value? It will be the function of next index comma 4. But here we are not making sure that this can be 5 also, because this can try 5 also. This will not try only 4, because the previous element is 4. So this will not try 4, it will try all other elements than 4. But if we take 5 here, then this will be strictly increasing. So we are missing out the information regarding 3 elements. So how to handle that? For 2, we simply added the before element. For 3, let's add the before element and the before element also. So we can track simply function of dp of, because there are many overlapping subproblems, so we can simply memorize that. So function of index number 1 and number 2. So number 1 is the before. For example, let's say we are at index I, and number 1 is this. this value in the final array, and number 2 is this value in the final array. So if these two are there, then it is very simple, because if these two are there, then we can try from all values from L to R. We will check whether adjacent are not equal, whether increasing or decreasing are there, and then we can take the possibility whether we are taking that element or not. So now it is very simple. But the time complexity is n into r square approximately, because the space complexity is at least this much, and all are up to 2e3. So it is approximately 2e3 whole cube, which is approximately 1e9, which we can't use. So now how to optimize it? So before that, let's check the code, how to just, so here before this, instead of using a variable, instead of using the number 1 or number 2, what if we just try to store the direction? For example, let's say we have 3 4, and let's say we have 390. So let's say we have these two. So these two are exactly same, right? Because the only thing is increasing, and this is also increasing. So if these both are increasing, like we are anyway storing 90, we are anyway storing 4 or 90 in the DP, but we are trying to remove the before element, so that 2e3 space or time can be decreased. So if we take 3 4, then what will be the next? It will be simply function of 2 comma 4. From index 2 we don't want to take 4, and from 390 the function of 2 comma 90. So this is what we thought, but till now. But how to remove these three? How to remove storing 3? So the only thing that we want is whether the previous two are increasing or decreasing. We don't want exact values of number 1 and number 2. We only want whether that is increasing or decreasing. If that is decreasing, then we will make sure that next value is more than the number 1 that we are storing in the parameter. And if it is increasing, then we will try to decrease the value than the number 1 which is in the parameter. So the only thing we exactly want is the number 1. We exactly want that, because we have to make sure that both elements are not equal. So we exactly want this. But instead of number 2, we can store a direction boolean, whether if it is 0, it means that the present is decreasing. If it is 1, this means increasing. So if this is 0, then we can take the possibility for present index more than the number 1, and then we can do, and we can solve. So function of index, number, and direction. So direction 0 means that the before 2 are decreasing, and now we are at this one. So now let's check the code for this. So function of length, number, and direction, and initially result is 0 if the direction is 0. So if the direction is 0, it means that this is decreased. So if this is decreased, then what is the possibility for present element? That should be more than this. If that is less than, all three are decreasing. So the direction is 0. So we want a more number than the number. So next is equal to number plus 1 less than m, next plus plus. So what is m? So before this, let's check other also. For example, let's say we have the range as 3 to 100, and let's say we have range of 0 to 97. So these both are same. Why these both are same? Because the only thing matters. For example, let's say we got subsequence, we got a subarray 3 4 2 here, 3 4 3 5 4 here. Let's say we got 3 4 3 5 4. So if there is a possibility of 3 5 4, then we can exactly get 0 to 1 also, just by subtracting 3 from all. Because if we got a subarray, if we got an array, we can reduce all by the same value, and even then the new array will be a valid one. 3 5 4 is valid, so 0 to 1 is also valid. So why we are concerned about 3? So simply L to R range is also can be considered as 0 to R minus L plus 1, because it is easy to deal with the lower numbers than bigger one. For example, let's say we have 1990. Let's say we have L to R from 1990 to 2000. So this is very exactly equal to 0 to 10, because any array that is achieved by using this can be exactly subtracted by 1990, and we can achieve the array in this. So simply m is equal to range r minus L plus 1. So L to R is decoded as 0 to R minus L plus 1. So now it is decreased, so we can try all the numbers greater than that. So number plus 1 till m. And now function of length minus 1, next, and 1. And similarly, so initially length is equal to n. We can do anyway, but this is just the idea of code. And then if the direction is 1, it means that it is increased. So now we have to decrease the value. So try for all the below values. So next is equal to 0 to next less than number, and next comma 0, because this is decreased. Because now we are taking low number, so this is decreased for the next iteration. So the parameter 0 and finally return result. But the time complexity is even 1e9 because the states are 1e3 and 1e3, but for every index we are looping through 1e3 and then we are finding the answer. So we are looping again for 1e3. So even now the time complexity is 1e9. Now how to reduce this? So before optimizing, let's just try to convert bottom up, because bottom up is very easy to see to check whether we can optimize anything or not. So what is the bottom up for this one? That is very simple. So there are two loops for now. The first one is index and the other one is the num, the before number. And then there are two other loops which we used exactly. Up is equal to down 0, and for up we will take 0. For down we will select 1. Why up is equal to 0? Because if the before one is 0, only then we can consider up for now, right? If the before is 0 decreasing, then only we can consider up now, which is increasing. So up and down, and then dp of 1 is equal to up and dp of 0 is equal to down. So this is the bottom of before. So where can we optimize this? Can we remove this loop, or can we remove this loop, or can we remove this loop? So here if we observe, there are three loops, right? What are those three loops? The first one is index, the second one is the previous number, the third one is the possibility for the present number, because we are looping through all the possible values, right? So why we are traversing from 0 to num? Because this is the possibility for the present value. So there are three loops. So time complexity is n cube, because there are nested loops. But what if we try to convert these two into a single loop like this? Because we have something like this, right? So in the inside loop of this we have other loop. But what if we try to have something like this, some loop here, and that loop is completed, and if we have some other loop, then the time complexity will be additive, because here they are nested. For example, here it is like this. That's why the time complexity will be multiplied. But what if we have something like two individual loops? Then the answer is very simple. Like the time complexity will be reduced, because time complexity of this plus time complexity of this. But here time complexity of this into time complexity of this. So now the main thing is how to remove this loop, how to remove extra loop. Without extra loop, can we just directly get this in O of 1 so that we can find the answer in very simple way? That is the main thing for now. So can we do that? Yes, because if we clearly observe, for example, if we are length, so if we clearly observe what we are doing, up is equal to dp of length minus 1 next and 0. So dp of length minus 1 next of 0. So what we want, dp of length minus 1 and some range of values and 0, and dp of length minus 1 some range of values and 1. These two are the only things that we are finding and increase our time complexity, because some range of values loop through often. So finding these is the biggest difficulty here, because this is taking off n cube. Like the net complexity is taking off n cube. So what if we try to remove this? What if we try to find this in of 1? Because for length we already came from length minus 1, but badly again we are looping through these when we are at length, because these are already computed for length minus 1 when we are at length minus 1. But when we are reaching length, again we are using a loop to find the values which are already computed before index, which is very bad, right? So what if we store the values? What if we try to store, and then what if we try to access in of 1? Then that will be very good. So simply we can use prefix sums. Why? Because what if we have something like dp of length minus 1 0 comma, like dp of length comma 1 0 0, dp of length minus 1 1 0, dp of length minus 1 I 0. So if the present possibility, if we are checking I, what if we have something like dp of length minus 1 from 0 to I, and dp of length minus 1 I to m minus 1. So if we have all this, sum is equal to prefix of I. If that is stored as prefix of I and all of this stored as suffix of I, then the loop can be broken down into one line. Because if we clearly observe, so up is equal to, so for finding up we are using an extra loop, but here we already got a prefix of I of 1. So we can simply use dp of length of num of 1 is equal to prefix of num minus 1, because for num we have to traverse from 0 to n minus 1, and for 0 we can start from num plus 1 to m minus 1. So instead of the loop we just try to boil down to one single variable, prefix and suffix. But how to find these? So how to get these sorted? So even this is simple, right? Let's check the code and observe how we are doing that. So initially only for one length, both are 1 because for only one the number is 1, and let's start from length 2. So when we are starting from 2, let's store two arrays, prefix and suffix, to directly store the value. So we store prefix and suffix, and now before going through the looping of number, before going through loop, just find the sum for the before indices, because when we are at length, all the computations completed for length minus 1. So even before going to loop through the present values of num, let's just find the prefix and suffix of the before arrays. So let's do for I to m, let's do for 0 to m. So for I is equal to 0 to m, then we already got length minus 1 vectors. So simply sum plus is equal to db of length minus 1, I and 0 mod, because we have to return mod low 1 and 7. So simply do mod, and after this prefix of I is equal to is, because we started from 0 to m, we will find the sum and we will store here, and we will find sum till 1, we will store in sum 1, we will find till 2, we will store in prefix 2. So in this way, if we try to store, then when we are doing for num, these are already stored, so there is no need of extra loop. Then we can just simply prefix of num minus 1, we can get the answer. So in this way we are trying to remove an extra loop. So this is O of m, and also similarly suffix. So similarly for suffix, store the values, and now loop through the print values. So num is equal to 0 to m, and now the exactly same loop before, but here no loop, we are simply using prefix and suffix directly in O of 1. So for up, consider prefix, and for down, consider suffix. And after that, we got this in of 1, and then initialize this to up and down. So after this, whole loop will be completed, and then finally, what will be the answer? So finally, after the whole array, what should we return? We should return. So the last element can be 0, the last element can be 1, the last element can be 2, it can be 3, and so on. So what will be final answer? It will be simply dp of n and num and 0 or 1, because the lastly it can be increasing or decreasing. We want the total number of arrays, that's it. So dp of last index, and num can be anything. It can be ending at 1, it can be ending at 500, and so on. So 0 to m, so last element can be anything, and the last can be 0 or 1 also. We don't care whether the last two elements are decreasing or increasing. So by summing this, we'll get all the possible arrays that we got, and similarly finally return answer. So in this way we can find the answer. So we made 3 loops, nested loops, just by, so here there are no nested loops, right? So this is one loop, this is one loop, this is also one loop. So it is simply of n, and outer loop is of n, so it will be of n square only. If we try to observe, we can space optimize this, because we are storing spaces 1 and 6. So if we clearly observe, even now the length, if we are at length, it is only dependent on length minus 1. So why to store the nums variable? So why to store nums? We can simply omit that also. So we can just store dp of value and the direction, dp of value and the direction. So both are 1, and then start from length to n. So prefix and suffix. So this will automatically make sure, for example, we are at index I. So if we are at index I, the present code after space optimization will ensure that the prefix and suffix are already set for the present index. If we are going to next, prefix and suffix will already be initialized. Let's say we have prefix and suffix, and then we are looping through 0 to m. So now there is no dp of other variable. So it is simply dp of I and 0, and prefix of I is equal to s, and similarly for suffix. So after this, even now we will have an extra loop for num, but we don't store that in the dp variable, in the dp, so that we can just try to find dp of I of 0, like instead what we have done before. So till now what we have done, we have done dp of length minus 1 and I, but here we will make sure that I will already be set. So instead of I, let's just find for dp of length minus 1 and 0 or 1. So dp of I and 0 and dp of 1, and then we will simply swap dp and ndp after updating dp and ndp. So in this way we can find the answer. So let's check the code. This is exactly the space optimized one. So instead of storing the second parameter number, we can simply space optimize that by storing dp and ndp. When we are doing for length ln, the dp will be the before one, and now we will find the ndp. So before going to next one, we will update the DP as NDP, because NDP is the new one, but NDP will be old for the next. So DP is equal to old one. So DP is equal to NDP for the next iteration. So simply before returning, swap these both. So this is the base case, and then prefix and suffix sums, and then find this in of one, and then swap this both, and similarly find the all numbers possible. If you have any doubts, comment below. See you in the next video.